We've been asked a bazillion times to do this video, so let's talk about what happens inside a nuclear reactor. Number 1, what is a nuclear reactor? It's a device that uses nuclear fission to produce heat for electricity. Like some forms of energy production, the fuel source does not burn, but the process generates tremendous heat. That's because it's all about splitting atoms. Number 2, nuclear fission explained. In nuclear fission, the nuclei of certain types of atoms, such as uranium-235, are split apart. This releases huge amounts of energy as well as additional neutrons. When those neutrons hit other atoms, they too split apart and the process repeats itself. Number 3, the fuel rods. So where exactly is this happening? In the fuel rods, they're long tubes filled with tiny cylindrical uranium pellets. This bundle of rods is the heart of the reactor. It's called the core. Number 4, the chain reaction. Here's how it works. First, one atom of uranium-235 captures a neutron. It becomes unstable and splits into 2 smaller atoms. This releases 2 or 3 neutrons which go on to cause fission in other atoms, leading to an explosion of energy. That's a lot of energy from just a few atoms, but it's a controlled explosion. Otherwise, we'd have a bomb on our hands. Number 5, control rods. These control rods are made of materials like boron or cadmium. They're inserted between the fuel rods and absorb excess neutrons. That way, instead of having an out-of-control meltdown, we get a nice sustainable chain reaction. Number 6, the coolant system. All that nuclear fission is generating a lot of heat, so to prevent the fuel rods from melting, we need to cool them down. That's where the coolant system comes in. It could be water, gas, or a liquid metal. Its job is to remove the heat from the core and move it somewhere else. Number 7, the steam generator. Next up, we have the steam generator. It's like a giant kettle. Heat from the coolant boils water into steam. And why do we want steam? Well, because it can drive turbines. Number 8, the turbine and generator. Let's take a look at how this works. The steam spins the turbine, which then spins the generator. Electricity is produced and sent out to the power grid. Number 9, the containment building. Remember all that nuclear fission we talked about earlier? Well, it produces not only heat, but also radiation. We don't want that radiation escaping. So everything we've discussed so far is housed inside a huge containment building. It's typically a thick shell made of concrete and steel designed to prevent any leaks of radiation. Number 10, types of reactors. Over the years, many different types of reactors have been developed. Some of the most common include the pressurized water reactor, or PWR, the boiling water reactor, or BUR, and the fast breeder. Each has its own unique features, but they all work based on the same principles of nuclear fission and the chain reaction. Number 11, nuclear waste. What happens to the fuel after it's used? Well, it doesn't just disappear. It remains highly radioactive for thousands of years. That's why spent fuel rods must be carefully stored away from people and the environment. It's a big challenge with no easy solutions. Number 12, radiation shielding. As we've mentioned, nuclear reactors produce radiation. To protect the workers who maintain the plant, thick layers of shielding are used. Materials like concrete, lead, and water are effective at absorbing or slowing down radiation. This helps create a safe working environment and prevents leaks outside the containment. Number 13, backup safety systems. Reactors have backup safety systems. Why is this important? Well, because if something goes wrong, these systems can kick in and help shut down the reactor. This helps prevent accidents and keeps everyone safe. It's kind of like having a backup generator when the power goes out. Number 14, meltdown risk. Now let's talk about a scary word, meltdown. What happens if the reactor gets too hot? Normally, the heat generated by fission is used to create steam and ultimately electricity. But if things go wrong, the reactor can overheat. If the temperature rises enough, it can melt through the container holding the fuel rods. This is called a meltdown, and it's a catastrophic event that should be avoided at all costs. Number 15, Chernobyl and Fukushima. There have been major nuclear accidents. Chernobyl in Ukraine and Fukushima in Japan. They made headlines around the world and raised concerns about nuclear power. These incidents led to changes in safety regulations and a reevaluation of nuclear policies worldwide. Lessons learned from these accidents continue to shape the nuclear industry today. Number 16, nuclear versus fossil fuel power. So how does nuclear power compare to burning fossil fuels like coal and natural gas? Nuclear power is considered cleaner because it doesn't produce carbon dioxide during operation. However, it is more controversial due to the challenges of dealing with nuclear waste and the potential risks of meltdowns. Both have their pros and cons and play a part in the global energy mix. Number 17, nuclear energy equals low carbon. Nuclear power is a low-carbon energy source. Unlike fossil fuels, it doesn't release carbon dioxide during operation. Instead, it produces huge amounts of energy by splitting atoms, generating heat, and converting it to electricity. Number 18, fusion versus fission. Let's talk about nuclear fusion. You may have heard it's what powers the sun. In fusion, lighter atoms are fused together to form heavier ones. This process releases even more energy than fission. But unlike fission, which we use now, fusion isn't widely available yet. Scientists are working hard to develop practical fusion reactors, but it's still mostly in the experimental stage. Number 19, mini reactors or SMISs. Small modular reactors are being developed as a promising alternative to traditional nuclear power plants. These reactors are smaller and can be manufactured in factories. Then they can be transported to where they're needed and connected to the grid. Proponents say they're safer and more flexible and could provide a consistent source of clean energy. Number 20, the future of nuclear power. Nuclear power has a controversial history, but it could be a key player in the future of clean energy. If technology continues to improve and safety concerns are addressed, it may offer a viable path toward a low-carbon future. Now it's time for a quick recap. Make sure you remember these important terms and concepts. Nuclear fission, chain reaction, control rods, coolant, steam generator, turbine, generator, containment building, meltdown, nuclear waste, radiation shielding, backup safety systems, pressurized water reactor, boiling water reactor, fast breeder, small modular reactor, nuclear fusion. So what did you think? Did this video make it easier to understand how nuclear power works? Let me know in the comments below. I love hearing your thoughts. Also, if you enjoyed the video, please consider giving it a thumbs up and subscribing for more science explainers. Thanks for watching. Keep thinking, and I'll see you in the next video.